Gentlemen, thank you so much. Appreciate your being here today. Everybody that's on the live stream, appreciate your being here today as well. Guess my camera's over here. As you know, today is another SCTE training event brought to you by the Gateway Chapter SCTE. We've got our friends from Frontier Broadband and Springbok here to show a little bit of stuff about MTDR, give you a little good information. Before we get started, I want to reintroduce myself. Most of you I've known for a few years now. Some of you we haven't met before. I'm Hunter. I work for Charter Communications. I'm in the IT side of the business, but network engineering specific. Again, most of you I've seen in trainings or we've passed each other, dealt with each other over the years. So I'm really, really happy to be here. Thank you, Madison, for hosting us today and having us be here. We really appreciate it. Real quick, I want to talk about SCTE, just a refresher, what all of you already know. SCTE has been around a long time, over 50 years. The entire mission, the entire goal of SCTE is to empower you folks, to give you the opportunity to grow your career, learn more, and not just the training sessions, which is what most folks in field operations end up doing, is just participating in the training sessions or vendor days or things like that. But really, it's also about networking. So get to know people, get to know the folks that come in here. These folks that are visiting here from out of state, you never know 10 years from now, 15 years from now, where your career takes you. They may be an opportunity for you to leverage for your career, or maybe just to solve a problem that you need to solve. So don't be shy. These folks that come, the vendors that come in, the folks from, say, another company like myself that come in, we're not doing it just for show. We're not doing it for money. We're literally doing it to make those connections with you as well. So don't be shy about introducing yourself if we haven't met before. If we have met and I don't remember you, don't be insulted. My wife will tell you I have no kind of memory whatsoever. So really appreciate your being here. I'm going to turn it over to Declan from Springbok, and please ask lots of questions. Anything you guys need, let us know. We're here for you, okay? Thank you so much.
All right, good morning. My name is Declan Hensley. I'm with Springbok. Just a little bit about myself before we get in. I've been with Springbok for just under a year. I am the newest member of the sales team, and I also work in production and repair. So I get to see them from boards to displays to batteries, everything. And I also get the opportunity to see how destroyed technicians can make these TDRs. I've even seen some of these TDRs come in with tire tread marks on them from people running them over. So we'll kind of jump in. I know you guys don't have Springbok TDRs, so we'll kind of just stay a little generalized kind of theory of operation. I'll kind of show off some of the cool stuff that Springbok can offer. But there's going to be several functions that correlate between the Springboks, the Greenleys, the old riser bonds. So we'll kind of try and touch on those. And there at the end, we'll jump on the Greenlee and I'll kind of show you some of the stuff that I found that we also have. Okay. As many of you guys might know, we also have an app. I'll kind of show that off a little bit towards the end. And then we will also do some waveform analysis. We'll talk about common stuff you'll see, uncommon stuff you'll see, kind of how to diagnose those. Okay. And like Hunter said, just jump in with any questions. Don't feel like you're interrupting me. Just go ahead and jump in. Okay, real quick before we start, just on a scale of 1 to 3, I want you guys to rate yourselves on your TDR knowledge. 3 is going to be your experts. You're going to find pretty much every fault. You're going to be pretty well versed in the TDR world. 2, somewhere in the middle, you find most of your faults, still struggle sometimes. And 1 is, I don't know how to spell TDR. Just 1 to 3. 3, 2. Okay. Whole goal today is just to get you guys up at least 1 point, at least teach you something, one thing. Okay. All right. So we'll kind of just jump into some of the basics of what TDRs are looking for and how they function. So basically what TDRs are looking for is impedance mismatches. And impedance is created when 2 metallic conductors are placed together and they run in parallel and equal distance to each other. So with impedance, we're just looking for the mismatches. We're looking for the pinholes. We're looking for the crushing when that space becomes closer than it should be. Okay? So basic principle of operation for a TDR. We like to think of it as like a radar gun. So TDRs basically send a pulse of energy down the line of cable on your chest. When that pulse of energy reaches a fault, it reflects some or all of that energy back to the TDR. Based on the time that it took to get there, it converts that time to a distance. So it's important to understand that these TDRs are time-based instruments. And I'll probably say that a few more times. They're time-based instruments. So one of the most important things to know how to manipulate is going to be pulse widths. And I know with the Greenlee especially, it kind of auto does its pulse width. We'll run through how to turn that off so you guys can manipulate it. I like to think of pulse widths similar to like vocal volume. If you guys are standing in the shop way over there, I'm probably going to have to yell at you, right? For you guys to be able to hear me clearly. If you're standing right next to me, I'm just whispering. So it's the same thing. Pulse dissipates over distance, so we're going to need a larger pulse width to cover further distances. Cool? One thing to keep in mind with pulse widths is as we increase the size of those, we're increasing blind spots right at launch. So that's where jumpers are going to kind of come in handy. Kind of the industry standard in cable TV is going to be about that 6 to 10 footer. And the reason for that is because we're usually working on the 1 to 25 nanosecond pulse width, just because you guys don't have super long runs, right? So for example, with a 25 nanosecond pulse width, we are literally shoving a 15-foot wide pulse of energy down the line of cable. So if you've got a fault in the first 15 feet, you're probably going to miss it because you're in that blind spot. Pulse widths are super important for long distances, but also for short. If you've got something super small in your waveform that you can't quite see, maybe a little bump in the pulse width might give you a little more clarity. Okay? Just makes those events a little larger. Okay, VOP. So like I said, TDRs are time-based instruments, so VOP is going to be super important. VOP is simply just a comparison to the speed of light. It's just a percentage. So at 100% VOP, we've got signal traveling at 186,400 miles per second. At 95%, or at whatever that number is, I'm not doing the math. Okay? So the important thing with VOP is just make sure that the TDR and the cable are speaking the same language, that we're going the same speed, because we're a time-based instrument. If our TDR is going too fast, it's going to skew our distances. If it's going too slow, it's going to skew our distances, right? Now, there's 3 ways to determine VOP. First and foremost is going to be super easy. Springbox TDRs, we've got pages and pages and pages of standard cables list, common cables, and their corresponding VOP. I'm not sure how you guys have a VOP list in these? You know? Yeah? Okay, cool. The other way, there's 2 other ways to kind of backdoor it if you don't know what your VOP is for whatever cable you're working with. Easiest one is going to be with a known length of cable. Say you've repaired a cable a week ago and you know there's a splice at 100 feet. Put your cursor on the splice. And you're not reading 100 feet. That means your VOP is off. So just adjust up and down until you get to close to 100 feet. Okay? The other way is the kind of backdoor VOP is with a bidirectional shot. If you shoot from A to B and B to A, marking your faults in both ways, marking the middle, that'll give you a true measurement. Okay? A lot of guys I see, especially in cable games, kind of forget about VOP. VOP is pretty important if you want to be accurate. If you're off by several percent, that's going to put you off several feet. And you guys are the ones digging the hole, right? Just be as accurate as you can with VOP. And here's just that standard cables list that we've got in Springbox TDRs. I'm not sure what your guys' looks like, but it's probably pretty similar. As you guys may know, VOP can change due to age, temperature, humidity, and different manufacturing runs. Obviously, most cables are going to have different VOPs just based on their manufacturer. Now, the difference between a cable that was buried in the Arizona that's been sitting in 110-degree ground for its whole life and the difference between something you just installed yesterday isn't going to be a huge difference. It's going to be about 2 to 3%. Okay? But if you're having troubles, you can't locate it, that's where those 2 ways to kind of backdoor the VOP is going to come in handy. If it's supposed to be 85, you're at 85 and you're several feet off, that's kind of how you can kind of backdoor it. Okay? Any questions on VOP so far? No? All right. Kind of just jump into some of the functions of Springbox TDRs. Everything, like I said, there's going to be some correlations. Has anybody here been to cable games and played with these at all? 1, 2, cool. Okay, so you guys at least have seen these before. So Springbox TDRs only have one physical button. We've got a full color LCD display. We've got the micro USB and splash proof BNC. Like I said, these instruments are pretty indestructible as we see them with tire tread marks on them. When open, obviously the biggest enemy for electronics is going to be water. And our biggest weak point is going to be our charging jack. So we've actually got a little metal cap that screws over the top of a charging jack to kind of just keep the water out. Okay, so regardless of what TDR I'm using, I always like to read the screen just like a book, top to bottom, left to right. So we'll just kind of walk through what we've got here on screen. At the top, we've got our footage ruler, just displaying how much footage we've got on the screen. See, we've got 100 to 500-ish feet of cable. Top right, we've got a Bluetooth icon, which we'll kind of talk about Bluetooth here in a little bit. We've got a battery icon and time for you. And then just below that, we've got our primary waveform with corresponding 3 cursors. One's going to be your launch. Zoom window 2 is going to be for cursor 2, and same with 3. It's important to understand that 2 and 3 are taking their measurements based off of the location of cursor 1. So I'm sure you guys use jumpers. It's important to zero out your jumper. We have a way to save location of a jumper. We don't really need to get into that. But if you guys are just using a 10-foot jumper, just make sure you remember to minus the 10-foot jump. Okay? All right. In the Zoom windows, we've got a footage reading, and we've also got our dB reading, which we'll kind of touch base on when we get to waveforms. Towards the bottom here, we've got our pulse width. Just sliding that sucker left and right. It's going to be how you change your pulse width. And you'll see as we increase, we'll see in Zoom window 1, we're seeing that our pulse width is physically getting larger. So that's where those blind spots are going to come to bite you, okay? Because even at a 5 nanosecond, on the 20, you can see that pulse getting larger right at launch, okay? Vertical gain is just a representation of zoom. We're not doing anything to the waveform. We're not making any events with any more energy. We're not doing anything there. We're just stretching the amplitude of the waveform to make those little events appear more clear. So we've got 2 numbers here. We've got 1x, 4x. 1x is going to be for your primary waveform, and 4 is going to be for your zoom windows, okay? So as we increase, we'll notice that some of these splices are getting larger, and the end of our cable is also getting larger. It's important to understand with vertical gain that there is a happy medium. Too much vertical gain, you're going to create problems that aren't there. So use vertical gain, zoom with your discretion, because you can be digging in the wrong spot if you're trying to look at stuff in here, right? Okay. Moving on to range. Range is just going to be your more cable, less cable button. So at our lowest range, we're looking at about 150 feet of cable. And as we crank that up, now we're looking at our 500 feet again, okay? Range and horizontal position kind of work hand in hand. Again, we're not doing anything to the waveform. We're not putting any energy. Nothing is changing. We're just changing how we view it. So horizontal position allows you to just slide the waveform left and right. So I think horizontal position is a super underutilized piece of, it's an underutilized function when it comes to TDRs. So for me, when I'm doing a test, I would plug into plant and zoom out, range out. I want to see the whole picture first. And then I would range back into our lowest setting, and I would just break everything up into 100-foot sections. And then use horizontal position to look at the rest of the waveform. Cool? All right. VOP, I'm sure my cable guy or cable tech guys know how to manipulate this. We just got our up and down arrows if you know the percentage for your cable that you're working with. Like I said, we've got our standard cables list here at the bottom. We've got, I think, 65 pages worth of VOP stored in there. We also have a favorites list. So if you're working with 10 cables pretty often, this is where you can kind of input those. We can just select any of these numbers. We can give it a name, give it a percentage, hit save, and it'll always be in there until you get rid of it. Okay. We also have a save start VOP button. That's if you're pretty consistently working with 88 for some reason. Every time the TDR kicks on, you can just have it start up on 88. All right. We'll kind of touch on some of the storage features of the Springbok TDRs. When in regards to the storage features, we also have a comment button. On the Pros, have a full-size keyboard for you to put job numbers, addresses. You find something unique, you got a splice at 100 feet or something like that. That's where you can input those comments. Right next to the comment button is where we've got our auto search. That's going to be just like what your test wizard is. Just a self-diagnostic tool. It's a really good jumping off point. It's not going to be your end all be all, just because the TDR isn't always right. So the TDR is basically just going to put markers at where it perceives as their events. It'll also auto range you, but it won't change vertical gain or pulse. And to get rid of those markers, all you got to do is just hit the erase markers button, and they're gone. So as you guys probably noticed, we've been looking at a recalled waveform this whole time. We've got a pretty good storage system on the Springbok TDRs. So the way to just go back to live is right there at the bottom. We'll be ready to shoot live again. I am not sure. Okay, cool. Okay, wonderful. So with Springbok TDRs, we can store up to 60 waveforms. And storage, I think, is going to be your best friend, especially if it's -10 out or it's raining or it's super hot. Storage feature allows you to do your test and then get your customers back online. You can diagnose everything from your truck as if you were looking at live plant. So with our recall feature here, we'll have up to 60 waveforms. Everything will be time and date stamped, and those comments will also be displayed up here. And like I said, this is just a good way for you to get your customers back online and do your diagnosis from somewhere else more comfortable. Cool? Yeah. And the comment button is where you're going to add those job types, addresses, job numbers, stuff like that. And those comments are going to be helpful if you're taking multiple shots in one day. We only have a delete all button, but if you guys do end up going Springbok at some point, just moves everything down one rung. So when you take the newest one, it'll get rid of the oldest one. Okay. We won't go too much into settings here, but we'll just kind of touch base on some stuff. The only thing we're really concerned about with the info screen is just the serial number. That's how we're going to connect via Bluetooth. Event markers, it's just changing the sensitivity or auto search. With the LCD brightness, similar to your phones, laptops, tablets, brighter your screen, faster your battery's going to die. And I'm sure you guys are familiar with batteries dying on these suckers. So with Springbok TDRs, we use nickel metal hydride batteries instead of lithium ion. The advantage of nickel metal hydride is they do not carry memory. So you can overcharge them, you can run them till they're dead, and it won't hurt the battery. The other advantage of nickel metal hydride is if your TDR has been sitting on the shelf for 2 months, haven't used it, it'll still probably have some juice in it. Okay? So generally, I'm around the 60 to 40% mark. Gives me 10 hours of continuous runtime. That's 10 hours of continuous testing. That's just not 10 hours of it just being on. You've got a lot of life and a lot of testing you can do with these TDRs. Okay, so then some of the other settings, if you guys want to work feet meters, we're always going to recommend you stay in a whole percentage for VOP. Having a decimal point is generally used in power. And V/2 is just a European measurement. Start at vertical gain. If you find you like a particular vertical gain, you want it to be your default every time you turn the TDR on, that's how you can do it. Startup range, totally personal preference. And then the filter level, we have a built-in RF filter on these TDRs. So at a filter level of 1, the TDR is only going to take 1 shot. And if you guys are encountering RF, just crank that sucker up to 64. It'll take 64 shots. It'll average them out, kind of bring down that noise floor. Makes it easier to look at. Okay. Zoom windows. If you don't like them, this is where we can hide them. auto shut off, pretty self-explanatory. And then these TDRs also do have a power filter. They also have an AC block, so they can shoot into power. Nothing's going to happen to the TDR itself. It'll be totally fine. The filtering also will just kind of clean up some of the noise. And then the pulses to save, that's just going to be what you save when you hit store. Okay. So we can change our time and date. We also have the ability to flip our screen if you guys want to carry a carabiner, hook that sucker up somewhere and use it hands-free. And then we also have the ability to invert colors if you guys are working at night, sensitive eyes. One thing to keep in mind with inverting color is it's just going to drain the battery faster and filling the screen up with more pixels of color. Okay. IFD mode. IFD mode is known as intermittent fault detection. So IFD mode is basically just the TDR taking a time lapse. So if you were to take a time lapse of the sunset on your phone or something, it's going to take a picture every 10 seconds or whatever it is. It's basically the same thing with the TDR. So if you've got a piece of aerial plant that you know has got something wrong, it's probably got micro shorts, it's got swirl chew, but nothing's showing up on the waveform itself. This is where IFD mode can come in handy. You can set it up, hit IFD mode, hit go. It'll take a waveform every 10 seconds or wherever you set it at. So if the wind blows and then you got your short, it'll pick that up. Okay. And then there's our exit buttons, how we're going to get back to the regular screen. Any questions on kind of the functions, features of Springbok TDRs or any other functions?
One thing we talked about maybe last night was in that IFD mode.
Mm-hmm. Correct. Yeah. Yeah. So the advantage of that is if you've got a waveform that looks good, but you know there's something wrong, it's a way for you to kind of force that short or force that that fault to come through. So it works really good with aerial cable. If you've got micro shorts that only pop up for just a second and you don't have enough time to measure where that is, IFD mode, you can set that up and just start shaking it, and those shorts will pop up and the TDR will catch it and form it into a waveform. So at least you know where to go. Mm-hmm.
On the altimeter that's at total record, 8 nuts,
Mm-hmm.
something like that.
All right. I will jump into the app real quick and just kind of show you how this works. Okay. So like I mentioned, these TDRs have a Bluetooth function, so where we can use our phones, tablets as if we were using the TDR. I'll just show you how to do this real quick. So this screen is just on my phone here. The way to hook up to these is just going to be in the top right. We'll hit download. It'll scan for any devices in the area. So mine's going to be the 539. Go ahead and select that, hit connect. And then up here is where all of those stored waveforms are going to be displayed with our time, date, and any comments that you've added. So I've just got a piece of test cable that we've got here in the office. We can change how many of the pulse widths we want to save. Just for the sake of time, I'm just going to do 2. Go ahead and select it, hit download. Okay, and now we can look at this waveform as if we were looking at it on TDR and as if we were on live plant, so we can manipulate pulse width. We can change our vertical gain. We can do range. We can do everything that we could on the TDR itself in our phone. Change VOP. We've got our standard cables list. We have our auto search. So it basically just gives you a little handheld TDR where you can diagnose stuff from the comfort of your truck. The other advantage of the app is going to be the shareability. So we have the ability to send these files as a PDF, and the PDF will look a lot like a screenshot. So it's important to understand that you got to have everything set. You'll have to have your comments, your VOP, pulse width, all that stuff. And then if you can send it as a tracker view file, like if you guys were to send something to me, you were having trouble diagnosing something, I would have you send it as a tracker view file, so then I can play with the waveform as if it were live as well. And we also have the ability to add comments here. Okay. Switch back over here to my computer. And this is what that PDF is going to look like. So it's basically just a screenshot. We've got our markers in place. We've got our comments at the bottom. And all of our stats with our VOP, pulse width, all that stuff at the bottom left. All right. We need to take a few-minute break. Cool. Yep. All right. Now we're going to take a peek at some common waveforms, stuff you'll probably see every day, and some stuff you probably won't see hardly at all. So we'll kind of start with just a pretty standard waveform here. So again, we go top to bottom, left to right. We've got our footage ruler here. We're looking at about 100 feet of cable. We've got our launch, and we've got a little splice here at about 7 feet. So like I said, I always like to range out and look at the entire waveform. This was where that horizontal position is going to come in handy if we want to slide left and right. We've got another little event here at about 60 feet and the end of our cable at 101 feet. So I like to show this slide just to kind of talk about opens and shorts. I'm sure you guys see these all the time. Those are the easy ones to figure out. And then talk about perfect measurements as well. So a perfect measurement is always going to be on the left-hand side of your event. 1.79 feet. The other reason I like to look at this slide in particular is to talk about reflections. So pulse dissipates over distance. So that pulse of energy is bouncing back and forth between the fault and the TDR until it goes away. So it stands to reason that after the end of our cable, there's probably going to be, if I can look this, some events afterwards. Now you wouldn't believe how many guys in cable games will tell me that this is the end of the cable or this is the end of the cable. Happens all the time. I understand why, because they're events. But this is just that pulse dissipating back and forth to the TDR. This is the end of our cable. Everything after here is just going to be reflections. There's 3 easy ways to identify a reflection. First and foremost is going to be spacing. So we've got the end of our cable is at about 100 feet. We've got a reflection at about 200 feet. Another one at 300, 400, until it eventually goes away. Right? Another way to identify a reflection is going to be amplitude. So you'll notice at the top of our short is much larger than this one. The amplitude is just shrinking as we go along. And the other easiest way is they're just inversing up and down. Okay? It does not. In this example, we've got our launch, and here's the end of our cable at 55 feet. But these aren't inversing. Is this the end of our cable? Anybody? No. Reflections. Because we've got the end of our cable at 56 feet, 112, and the amplitude is shrinking. Cool? All right. Can TDRs shoot through actives? No. Good answer. Can they shoot through passives? Wonderful. So this is just an example of what taps look like. So they're passives, so they're not going to skew our waveform in any way. TDR can shoot through them. It's also, I'd like to, good one to show what pulse widths will do to some of these waveforms. So as we're increasing, we're making our waveform look all goofy, right? Our measurements are still correct. We're just changing how much energy is being pushed down that line. So it's making these taps look all goofy. So it's important to understand that sometimes a larger pulse width isn't always going to be better. Sometimes the little guys are going to be better for finding smaller details and to not skew your waveform. All right, and then this next one, this is just to show what an amp would look like. It's a huge mouse, I can't control it. All right, so we've got a tap here at 340 feet. We've got another tap here at 500-ish feet. And then we hit our amp, which is giving us this squiggly here at the end. Okay? This next one is going to be an example of power on the line. It's going to all be skewed. You're not going to get anything from there. Sorry? Ask it again for me. No, I know. Mm-hmm. Correct. Okay, so the question was, everything beyond an amp is just not going to be good data, and that is correct. The amplifier is just going to skew everything. It's going to mess with the pulse width, most importantly, so it's going to make everything look goofy. It's because it's putting additional power on the line. Correct. All right. Moving on to power. Power is going to be an easy one to identify just because of how uniform the waveform is. So we'll notice that our peaks are all at the same height. Everything looks pretty uniform. Power is going to be a real pain in the neck because if you've got a tiny splice in here, odds are you're not going to be able to see it with all this noise, right? We can see the end of our cable here at a short at 480 feet, but if there's anything in between here, we're going to have a tough time identifying anything. So we always suggest, if you can do it and do it safely, always take power off the line. It'll clean up your waveform. Okay? This is an example of RF. Pretty easy way to identify RF is with nothing's uniform. It's all pretty messy. Again, same thing with powers. We're going to really struggle to see anything little in between our launch and the termination of our cable. Like I mentioned earlier with our RF filtering on the Springbok TDRs, we have the ability to crank that filtering up. So this is at just a single filter, and this next one is at 64. We'll notice just a lot of that stuff gets smaller, and it makes it a little bit easier to see. Again, it's probably going to be tough to find any splices or anything in between here, right? And here is the exact same waveform with the RF off. Cool. Any questions on RF, power, taps? Splitters? Correct. So splitters, they can pass through splitters, but something to keep in mind with splitters is you're splitting your pulse. So the energy is now going from one cable to two cables. So the distances beyond the splitters are going to be goofed. Okay? Exactly. Yep, we do not have the ability to distinguish which direction the pulse is going as well. So that's where those bidirectional shots are going to come in handy. I'd go to the splitter and then go beyond the splitter and shoot back towards the splitter is what I would do. Okay? Does anybody here use alligator clips? Good answer. We like to hear. Alligator clips are fine. They do their job well enough. But I just want you guys to take a peek here at the launch. With alligator clips, all we're doing is creating an impedance mismatch at launch. So as we've looked at all of these launches are about 3 to 5 feet wide. When looking through an alligator clip, our launcher is now 25 feet wide. So I'm glad to hear you guys aren't using alligator clips. Best connection you're going to be able to do is just with a piece of coax, BNCs straight in there, okay? An appropriate alternative would be test probes. Again, it's not super great, but our launch is still a little bit bigger, but significantly smaller than the alligator clip launch, okay? This is an example of water damage on your line. Water is going to be probably your biggest adversary when it comes to diagnosing waveforms. It could look a lot worse than this. It could look a lot better than this. Water is always such a case-by-case scenario. Always going to suggest you start with your fittings. Not the easiest solution, but it's a place to start. Water is also going to skew your pulse width because then we're trying to push energy through water. It slows it down. And then it's going to skew with our distances as well. All right. I'm going to move on to an example of squirrel chew. Squirrel chew, again, like water, could look like nothing. It could look like a perfect waveform with micro shorts, or it could look a lot worse than this. This is probably one of the worst case scenarios with squirrel chew. And those are just going to be those steep drops in the short when the center conductor is touching the outer sheath. Okay?
Idea squirrel chews are.
IFD mode will come in handy, especially with squirrel chew, because if this waveform were to look like this, it looks clean, nothing's showing up. That's where that IFD mode will come in handy. If you get up there and shake that cable, it'll make all of these little guys pop up for you, and it'll document those.
Another question on squirrel chew. Is there anything about the length of what is going to be something's wrong with the waveform equivalent to the length of damage you might be facing, or you can't?
It's tough because shorts can be micro shorts again, or they can be huge. I guess I don't quite understand your question.
So if you look at, we go out to about 125 feet of ground because of the grade. 25 feet of ground.
Not necessarily, because your waveform is going to be skewed from this point on because of our dB loss, which I need to touch back on. It could mean that you've got 125 feet of damage, but this waveform could be just completely skewed based on how low this short is. So this is where I would start. Nice thing with squirrel chews is it's very obvious if you've got a ton of damage. But the rest of our pulse width beyond this point is going to be skewed.
This be where you stand out.
Meaning increasing pulse width?
Yeah, and maybe not. Increasing pulse width and looking for things that are not similar in distances and rate.
I see what you're saying. Okay. So yes, so in regards to reflections, we know these are not reflections because of everything we talked about. We've got our biggest event here is at 40 feet. And we don't have something that looks identical to it at 80 feet. Yeah. Okay, so within these zoom windows, we will notice that we've got a footage reading and we've also got a dB reading here. So dB is just another tool that is super underutilized when it comes to TDRs. So dB is just a measurement of how much signal is traveling down the cable. So as we look at this one, we're in the high 50s, mid 50s as we scan along here. dB is a very useful tool if your waveform looks clean and it looks good. We've actually found bad faceplates on taps using dB. So like for this one example, we're again in the mid 60s or so. Tap, we're obviously going to have some loss. So we're around 30. And at our next tap, we've got about 34. Keeping dB in mind is if this number were 12 or 8, it's at least a place to start. I think dB is, again, super underutilized. It's already there. It's built in. So, I mean, if your waveform looks good, you can't find anything, maybe start looking at dB. Okay? Yes.
dB, so you're sitting at 50 before you hit that first event.
Yes.
That power of the pulse event.
Not necessarily. Yes.
Hit that event. Afterwards, it's gonna have 7. Okay, so
It'll return to, yep.
So that event, that just means you get 27 dB of loss right there, or 27 dB of reflection.
It's of loss, because a tap, you're going to be taking some of that signal away, right?
True return loss.
Yes. So dB is also known as dBRL, decibels of return loss. So if we're sitting here in the mid 50s and then we've got our tap, it's just signifying that we've lost some signal from here to here.
You can look up specifications of paths to find out if they return off.
Yes.
Path advice where you have something covered that path advice.
So we can read that whatever show is not faster.
Forward.
Yeah.
We're going for that.
So like in this example, if we know that our tap should be about 30-ish of loss, and we've got 40 or 50, then we know we've got a real problem. Okay. Any other questions for me?
And you had mentioned micro shorts. Yeah, I'm not 100% certain what that means.
Okay.
Can you go into a little more depth in detail what you first said?
Yes. So let's zoom in here a little bit. So this is a pretty standard looking short here. We can see that it is, I mean, it's very apparent that it is a short. Huge dip from our standard baseline. So micro shorts can be examples of slightly crushed cable. It can be a pinhole in the cable. It's just, so if you've got your center conductor and you got your outer sheath and it's only scrunched a tiny bit, that's only going to give you a micro short. Micro shorts can be so small that the TDR won't pick it up. Back here, sorry. Kurt, do you know the answer to that?
It's not a dead short, basically.
So micro shorts are just very, very small, like pinholes. Something that you're going to have a real hard time seeing on a TDR, even if it's there. Very small pulse width, and using your vertical gain to make these events as visible as possible. If we were to, correct.
Electrically speaking, a pinhole doesn't possible that micro trays and waves and what's restricted. That's what that is like. Have something where the one conductor is closer to the other conductor but not touching.
Mm-hmm.
H for short, maybe that's what we mean by micro short.
Yes.
Which is just a significant change in
Mhm.
short at all.
Yep.
Sure. I'm not pressing to be difficult. I mean, it's short, because micro short, like I said, a standard term for NPP other people.
It's a standard term for a waveform signature. So any dip
in your weight for it. And anything that goes up is a no.
And so a smaller.
So a small one
mini
is
like-
really my column.
Okay,
Big boat.
I'm tracking.
Yeah.
I would say it would be good to know that if it's something like you described as a pinhole, it's not a change in distance between two and that. That's what we're calling it. It's actually been trying this guy.
Yeah.
That's all there is.
It doesn't present itself as just like one event and like multiple events, like there was small, sure. I'll let you guys read it. A micro short, if it's a pinhole like that, you're probably gonna see a big blip and it's gonna see like that. So, I mean, the smaller the impedance or the smaller the issue, the less reflections you're gonna have, right?
Because shorts are created when we've got our outer sheath and our center conductor. When they're slightly closer than they should be, that's creating the impedance mismatch. Okay. And shorts are going to be the downwards inflections. That's when the center conductor and the outer sheath are getting closer to each other. And opens are going to be when we've got a full cut. That's just the total loss of correct. Yeah. Mhm. Yeah.
Now, at least on this,
This open, but you get smaller and wider. Slices, one of those big apart, got a lot of weight. Making another down where they make a connection, but it's not.
It'd be the same thing on your pinhole for the sheet.
Yep.
Right? As that galvanic corrosion starts to grow between the sheet and the center conductor and that pinhole, then it could go bigger than, I mean, I guess then you would classify it as more of a short than, you know what I mean, than just an impedance.
Mhm.
What you just described.
how does that show up on the something different?
Like if it's responses to the low end, you got that?
Most of the time you see the water in it. I mean, that from what I've seen, you know what I mean, if it's coax, you find a pinhole, you know what I mean, it's in the ground, that's
No,
what
it's
you'll
just
first
like
notice.
water.
Yeah, you can tell it's stuck the water in there, or find a bad spot.
Most of the time, no,
Okay, cool. Some of it depends on how far away you are from the ball. Right?
Oh, definitely.
If you're a mile away from it, it's
You'll
not
never-
look the same as if you're 200 feet.
Yeah.
It doesn't factor in sag, does it? Yeah.
No. Because it's no, yeah, I understand. It's just because it's
12, 13. Yep.
mhm.
It's longer than 12.
Yeah, yeah. No, that's longer than you think.
And it won't show up on the TDR because we're not creating any impairments in the impedance. Because the distance between the semiconductor and the outer sheath are staying the same, even though they're bending.
Well, no,
But
the sag
distance,
counters.
distance.
Yeah. Correct.
Your wheeled off footage pull.
Yep.
Is not the same as the distance. that
Yep.
the pin is coming.
Yep.
Which brings another question, as far as I'm concerned, I'm gonna drown you in these questions. Is, how often are you guys, before you answer, using your TDRs to troubleshoot issues with it?
Not a whole lot.
You rare? Since I would guess, my guess would be that's taking anything with it. You guys see that one minute later, you know, TDR happening with customers? Or you, pretty common, all there. Good folks.
Especially different areas of the country. Like Philly's got a ton of aerial.
Yeah.
And I was out in North Carolina, I think, and they've got mostly buried.
And all fairness, we're picking apart the physical things defined in the system.
Correct. Yeah. Yeah, your clear cut opens and shorts are going to be super easy. It's the stuff that's hard to find that I want to make sure you guys can identify.
That makes sense. And I
Yeah.
appreciate your kind of diving in a little bit deeper, but I think, I'm being selfish. Everybody else in the room, they go, you're stupid, but they're going to do this stuff. But for me, that's the only way I can.
Yep. Is there anything else you guys want me to touch on or look at again, or any questions?
So back to basics, I guess. Coax, the cable is 75 ohms. We have mismatches or impedance mismatches, what we're talking about. Like you said, shorts or downs, opens are up.
Mm-hmm.
One thing we have done in the past to test the end of the cable, because you see the huge open there, you can actually put a 75 ohm resistor terminator on that.
Mm-hmm.
See that cable go flatline.
Yep.
So that will check the end of your cable, make sure you don't have a bad connector right there at the end. Kind of point that out.
And to Scott's point, and Leonard's point, typically that's in an underground plant where we were breaking things apart. We very rarely shoot live.
Mm-hmm.
Cable.
Yeah.
I think for rare, we probably should do it. Breaking things apart, like shrink off and doing all that. Part of the process for it, so.
Yeah.
We can just determine that.
Mhm. Yep. That also reminds me, when we're talking about reflections, if you're having trouble diagnosing if this is the end of the cable or if this is the end of the cable, you can always go to the other end and short that cable out, and it should flip to a short. And if the second one goes back to an open, that's how you know they're flipping each other. So you can know that that's the end of your cable if this then drops to a short. Okay. That's good. All I got for you.
Any other questions, Deb? You find a lot of reduction of shooting live with or?
Yeah. That's where the storage and the app and that kind of stuff can come in handy, because you can terminate your line and then store everything and look at it as if you were looking at a live shot. And I know you guys have that storage ability as well. So that's where that advantage comes from.
They also have the ability to take two shots of the raffle.
Mm-hmm.
One direction and the other direction. Upload those files into Tracker View and then overlay them. Both sides. Yeah, coming.
Yeah. So like this one, we can overlay the one with our RF off. Then we can just look at them both.
That's pretty cool.
And you can also do that on the app as well. Yeah, and if you can display your damaged waveform and then your repaired waveform and show them both in one shot.
I was on that gas. Is there a use case? Trying to make a kitchen potato, but is there a use case coming up from people here in the office? We on the laptop. Capture the tracker view file and just send it to you if you have this set up. That way
Yeah.
you guys are looking at it together, but you don't have to have everyone out there to look at it and just try to this on your site, something like that.
We have that capability is what we have, but
These
that's
guys do that too.
certainly nice. But that's different levels of technician been doing
Mm-hmm.
many times, but we never touched the PDR
Yeah, for sure.
today. So be able to send somebody out, trace, and I can just
Yep.
everything like on there. I think that's valuable.
Get a second set of eyes on it. Yep.
Especially if it's, they get full of things outside.
Yeah.
Yeah.
Absolutely. Send stuff to shop and other people. What am I missing? That's
Yeah. For sure.
And did I understand correctly, the way that the files get saved? It's really just doing multiple shots at different pulse rates Together in the tracker we file, and the other person is looking, they're not doing anything, they're just changing the view. They're not shooting, it's not reshooting any more. It's
Just take it every way
multiple
for
shots,
Yeah.
stick it all in one file.
Yep.
That's the way it works.
I'm not sure exactly how to put it.
And it goes the same.
I can change cursor.
Okay. So
Yep.
it must be both.
And like yours, it depends on how you say it.
Yeah, if it's a PDF, I can't do anything with it.
It's, you know, picture based.
If it's a tracker view, then I can play with it. Cool.
Else have any questions?
You have any other questions, Frank?
I got a question first for Brian. What's the saying about the water and cable versus the suck out? The water resistance stands firm, high, low resistance stands out, high resistance.